fresh air, clean water, and fertile soil. Three natural resources that are so familiar that we often take them for granted. But it's not like that everywhere. In many large cities, a thick layer of smoke and fog may hang overhead, making breathing more difficult. In some areas, rivers and lakes are covered by an oily film, killing a large portion of the fish and other sea life. And in other places, the land is so scarred with litter and debris that nothing will grow. Air, water, and soil are three of our most important natural resources. They are also renewable resources because, as they are being used, recycled air, water, and soil are being added to the earth. A natural resource is a valuable material found in nature and used by people to meet their needs. Not only are air, water, and soil valuable resources, without them, we could not live. Let's take a closer look at these resources to see why they are so important to us. The Earth is covered by a blanket of air that is called the atmosphere. Without the Earth's atmosphere, there would be no winds, water, clouds, or sky. The air shields the Earth from certain harmful rays of the sun and helps keep the Earth's surface from being too hot or too cold. Air is a mixture of many kinds of gases. About 78% of the air is made up of a gas called nitrogen. About 21% of the air is oxygen, and there are small amounts of water vapor, carbon dioxide, argon, helium, as well as some other gases. You must breathe air to stay alive, and every time we breathe, we take in oxygen. The oxygen combines with food we have eaten to give us energy. When we breathe out, carbon dioxide is released into the atmosphere. This gas is very important to green plants. Green plants use the carbon dioxide, and together with sunlight, they make food and give off the oxygen that we breathe in. Thus, the air is part of an important cycle between people and plants. And air is a renewable resource, with recycled air constantly being added to the atmosphere. Water is another renewable natural resource that is vital to both plants and animals. The supply of water is renewed in a natural cycle called the water cycle. Water evaporates and rises into the air as water vapor. As it cools, the water vapor changes to liquid and falls back to Earth in the form of rain, snow, sleet, or hail. Scientists estimate that each day the sun evaporates 1 trillion tons of water from the oceans and continents and pumps it into the atmosphere as water vapor. Each day the same amount of vapor condenses and falls as some kind of precipitation. In fact, water is the most common substance on Earth, covering 70% of the Earth's surface and making up about 2/3 of the human body. All animals, plants, and human beings depend on water for life. There are some parts of the world, however, where water is very scarce. Throughout history, great civilizations have risen where water supplies were plentiful, and fallen when water supplies failed. Today we use huge quantities of water for household chores such as washing, doing dishes, cooking, and watering the lawn. Our demand for water is constantly increasing. It is estimated that each person uses an average of 87 gallons of water per day. In addition, there are many industrial uses for water, such as for irrigation, for cooling, and for electricity. Another valuable resource that we cannot live without is soil. Much of our food, clothing, and shelter is derived from the soil. All life on Earth depends on soil as either a direct or indirect source of food. Plants rooted in the soil obtain nutrients from it. Animals get their nutrients from plants or from animals that eat plants. Certain microbes, such as bacteria and fungi, cause organisms in the soil to decay. This part of the soil is called humus, and this process helps return nutrients to the soil. In addition, many kinds of animals find shelter in the soil. Rabbits, foxes, prairie dogs, and some kinds of owls burrow in the soil. Like air and water, soil is a renewable resource. Soil is a mixture of rock particles, minerals, organic materials, and water. Soil begins to form when environmental forces such as wind and water erosion break down rocks and similar materials that lie on or near the Earth's surface. This process takes millions of years. Wind and water erosion also destroys good soil, washing it down hills and into rivers. Thus, soil is constantly being formed and eroded. Since air, water, and soil are renewable natural resources, the Earth should have a plentiful supply. However, many people are concerned about the quality of these resources. Two things that threaten our natural resources are the growth of human population and the misuse of technology. For many centuries, the main effect humankind had on the air was to add smoke from fires set in the grasslands and forests. During the Industrial Revolution, smokestacks began to dot the city skylines. Then black smoke was not a sign of pollution, but a symbol of progress. Today, modern industries burn coal, oil, and natural gas, often allowing harmful waste products into the air. Automobiles are also a major source of pollution. Car exhausts discharge carbon monoxide, a poisonous gas, into the air. Carbon monoxide is the chief element in smog. Smog occurs when the sun causes poisonous gases and particles in the air to react. This polluted air, which looks like a dirty fog, may get trapped in an area for several days. This air can be difficult to breathe and unhealthy for you. In fact, most large cities have some smog. Cities in Southern California may be covered with smog for as many as 200 days a year. Today, federal and state laws require cars to have special equipment to reduce the amount of carbon monoxide that is let into the air. And many cities are attempting to clean up the air by requiring factories and power plants to remove the harmful chemicals before releasing waste products into the atmosphere. Just as clean air is important to good health, clean water is also vital. Harmful germs and bacteria can live in water and spread disease. In 1900, 27,000 Americans died of typhoid fever, a disease that is passed on through contaminated water. Water pollution occurs when wastes are dumped into rivers, lakes, and oceans. The three main kinds of water pollution are sewage, or human wastes and garbage, waste from agriculture, mainly chemical fertilizers and pesticides that are washed into the water system, and industrial wastes, byproducts of factories that are released into lakes, rivers, and streams. Polluted water cannot be used for drinking, recreation, farming, or industry. Through modern technology, we have learned to manage our water. Dams can turn rivers as large as the Tennessee on or off like a faucet. Highly sophisticated water treatment facilities have been constructed to purify our water and transport it to where it is needed. Massive efforts have been undertaken by government, industry, and private citizens to restore the water quality of many rivers, lakes, and streams. The cleanup of the Hudson River in New York, the Cuyahoga in Cleveland, and Lake Washington in Seattle are just a few examples of successful efforts to make our water cleaner and safer. And the government of the United States has established a uniform standard for all drinking water in order to reduce the amount of harmful bacteria, chemicals, and metals that it contains. Many of the causes of air and water pollution related to the misuse of technology also contribute to soil pollution. Waste from factories are often buried in the ground. Eventually, the chemicals leak out of the barrels they were stored in and poison the ground. The chemicals can get into the water and become a danger to plants, animals, and people. Every day, people throw away millions of tons of trash. In the past, solid waste of this kind was dumped on top of the land. Today, many cities bury trash in sanitary landfills. And many of the cans, bottles, and papers can be recycled and used again. Proper soil conservation methods will keep soil fertile so it can be used over and over again. Crop rotation and using fertilizers will help replace important minerals. Soil erosion can be prevented by planting cover crops, strip cropping, and contour plowing. Recently, scientists have been investigating other ways pollution is changing our environment. One of these is called acid rain. Acid rain destroys the ability of soil to support plant growth, as well as destroying the plants themselves. It also pollutes bodies of water by raising the acidity level so that the offspring of fish and other living organisms cannot survive. And acid rain eats away paint and stone materials, doing damage to buildings, bridges, and statues. Scientists believe that acid rain is caused by burning coal, oil, and natural gas. Pollutants, particularly sulfur dioxide and nitrogen oxide, mix with water in the air and then fall to the ground as acid rain or some other form of precipitation. Because pollution in one area may drift to another in the form of acid rain, this has become a worldwide problem. Most noticeably, it has affected parts of northeastern United States and Canada. Adirondack Park in New York State, for instance, is a protected forest area of 2 million acres. It is far from any major source of pollution. However, the natural systems there are changing due to acid rain. The needles and leaves on the spruce and birch trees have turned brown, and the fish population in many lakes has died. Another pollution problem of global proportions has to do with the destruction of a part of the atmosphere known as the ozone layer. Scientists believe that when certain chemicals called chlorofluorocarbons, which are used as coolants in refrigerators and air conditioners as well as in industry, are released into the air, they rise high into the stratosphere and set off a chemical reaction that destroys ozone. Scientists are not sure of all the ways the reduction of the ozone layer will affect us, but they know ozone screens out harmful ultraviolet light from the sun that can cause skin cancer. It is but another example of humans altering the Earth's surface and changing the atmosphere. The consequences of this we may not know until it is too late. Another theory, known as the greenhouse effect, believes that the carbon dioxide in the air is causing the atmosphere to react like a greenhouse. It lets in the warming rays of the sun, but keeps excess heat from radiating back into space. This may hasten a global warming trend that would raise the average temperature of the Earth and affect the climate, vegetation, and level of the oceans, and consequently change the balance of the Earth's living systems. Although these problems seem massive and the solutions are difficult and complex, it is important to remember that air, water, and soil, 3 natural resources that are vital to life, are renewable resources. Thus, if government, industry, and private citizens work together in harmony with our environment, we will be able to enjoy air, water, and soil that is clean, safe, and plentiful.
Herds of zebras roaming the African savanna. Giant redwood trees branching high into the California sky. a bald eagle soaring over a western mountaintop, a whale swimming to the water's surface for air. These animals and plants represent some of the most spectacular wildlife on Earth. They are natural resources that we have taken special precautions to protect. However, all wildlife, even the squirrels gathering nuts, or the cows munching on the prairie grass, and the fungi growing on a rotting log, are valuable resources. Wildlife is important to people for several reasons. Many people appreciate the beauty of nature that is expressed in the different kinds of plants and animals that enrich our planet. Plants and animals are also important for scientific reasons. By studying plants and animals, scientists can learn about various life processes, and even about human body functions and human behavior. The study of some plants and animals may lead to the development of new medicines and the cure or prevention of certain diseases. Wildlife has an economic value to our society. Plants and animals provide many products that are bought and sold, as well as providing us with food, clothing, and shelter. But the most important value of wildlife is the role that every plant and animal plays in helping to maintain the balanced living systems that exist between all organisms and the environment. For life to survive, these systems must continue to function. The loss of any species threatens the survival of other forms of life. In this intricate web of relationships, every form of life affects every other form. When a drastic change occurs in the community of living things, the balance of nature is upset. The study of the relationships that exist among organisms and the environment is called ecology. Understanding ecology enables people to manage organisms and the environment in a better way. The ecosystems include all living and non-living things in a community. An ecosystem may be a pond, a forest, a meadow, or even a schoolyard. Some ecosystems are on land, others are in fresh water, and others are in the ocean. The place where a plant or animal lives is called a habitat. The role of a living thing within its habitat is called its niche. An animal's niche is defined by what an animal eats, by what eats the animal, by how the animal protects itself, and by how the animal adjusts to its environment. The various forms of life in any ecosystem all have a common need for energy. The source of life's energy is the sun. A food chain shows how this energy is passed from one organism to another. Green plants change the sun's energy into a form that can be used. Green plants, therefore, are producers. Producers make their own food from non-living materials. They use sunlight, carbon dioxide, and water to make food. Food provides energy for them and other organisms. Animals cannot make their own food. They are consumers. They get their energy from green plants. Animals that depend directly on green plants are first-level consumers. First-level consumers include birds, deer, rabbits, cows, and others that eat the leaves, roots, flowers, seeds, or fruits of green plants. Consumers that do not eat plants, such as these cheetahs, are second-level consumers. They get their energy by eating other organisms that have eaten plants, that is, from the first-level consumers. They also feed on second-level consumers. A spider eating an insect or a hawk capturing its prey are examples of second-level consumers. Decomposers are another type of organism. They are the final link in the food chain, breaking down the remains of dead plants and animals. Decomposers such as fungi and bacteria help to return organic matter to the soil and water. Since most consumers eat more than one kind of food, They are usually part of many food chains. Food chains that overlap make up a food web. For example, in an open meadow ecosystem, one food chain consists of a mouse which eats grass seeds. A snake eats the mouse and a hawk eats the snake. But the meadow is made up of overlapping food chains or a food web. Grass seed is food for both mice and rabbits. Dead grass is food for worms and insects. Beetles feed on small dead animals and plants. Caterpillars, worms, and seeds are food for the blue jays. Snakes eat mice and rabbits, and hawks eat mice, rabbits, and snakes. Thus, you can begin to see the intricate nature of the relationships within an ecosystem. In addition to food chains, scientists use a food or energy pyramid to represent the relative numbers of plants and animals in an area. The amount of producers in an ecosystem is always much larger than the first-level consumers. They form the base of the pyramid. More producers are needed to keep alive a smaller number of consumers. Similarly, the amount of first-level consumers is always much larger than the amount of second-level consumers. Over long periods of time, environments slowly change. New kinds of plants and animals have developed, and others have died out. When an entire species, or single kind of plant or animal, dies out, it is said to be extinct. Extinct populations can never be brought back to life. When a plant or animal becomes extinct, such as this great auk, it disrupts the ecosystem. A link is missing in the food chain. In some areas of northern United States and Canada, wolves have been killed off by hunters. The moose, deer, and elk populations, which the wolves fed on, began to grow out of control until the animals ran out of food or until disease swept through the herd. The wolves had been a natural control and an important part of the food chain. Some species of plants and animals have become extinct because of natural causes. Animals may disappear from certain areas because they do not provide a suitable environment. Climate may be too cold or dry. Food may be scarce, or other animals may be competing for that area. However, in modern times, the activities of human beings and human population growth have been the greatest danger to wildlife. People have upset the balance of nature in several ways. People hunt many kinds of animal for their fur, hide, meat, or oil. They have cleared forests, drained swamps, and dammed rivers to clear the way for agriculture and industry. Animals die out because their special living areas, or habitats, are destroyed. For example, the Everglades kite is a kind of bird that depends on a single kind of snail that lives in the marshes and lakes of Florida. Since the marshes and lakes are being destroyed by people, the kite's food supply is disappearing, and so is the kite. Animals and plants, like the Everglades kites, that are close to becoming extinct are called endangered species. By some estimates, over 170 different kinds of animals and 1,700 kinds of plants in the world are considered endangered species. Other endangered animals include the bald eagle, the California condor, and the whooping crane. Destruction of wildlife habitats by people is the major reason for the endangerment and extinction of wildlife species. The key to a healthy, stable environment is a diversity of wildlife. In areas such as the frozen Arctic, the communities of plants and animals are very simple. If one part of the system is damaged, many parts may be affected. In the lush tropics, however, plant and animal communities are much more complex. Living things are not dependent on just a few plants and animals. When tropical communities are damaged, they usually recover quickly. To maintain the variety of life, we must make sure that many kinds of plants and animals exist. Environmental scientists are learning how to better manage wildlife and protect endangered species. A few years ago, the alligator was hunted for its hide, which was used to make wallets, handbags, and other items. The swamps where the alligator lived were being drained to make way for houses, highways, and shopping areas. The alligator became an endangered species. People concerned about the environment became aware of this situation. Laws were passed to protect the alligator's habitat and make it illegal to hunt them. Alligator farms were begun. The alligator is safe from extinction, at least for now. The establishment of wilderness areas, wildlife refuges, and national and state parks are all ways of helping to protect our environment. These areas also provide a kind of outdoor laboratory in which to study the relationships between animals, plants, and the environment. Since our lives are closely interwoven with the natural world, we should learn all we can about it. For it seems that our survival depends on keeping the Earth's wildlife resources healthy, stable, and flourishing.
Taking a ride in a car, cooking dinner on the stove, and turning on a light to read are all activities that require energy. We use energy to work, to provide warmth, and to move people and goods from place to place. Modern society uses huge amounts of energy to run all the machines and equipment in today's world. But will these energy resources always be there when we need them? Many scientists believe they will not. They think our current supply of resources is running out. This program will examine the most common energy resources: coal, oil, and natural gas, and also discuss how nuclear energy fits into this complex situation. Coal, oil, and natural gas are referred to as fossil fuels because they are formed from the changed remains of organisms that lived millions of years ago. When fossil fuels are burned, energy is released. Because it takes millions of years for coal, oil, and natural gas to form, they are considered non-renewable resources. Once the supply of these resources is used, they are lost forever. Coal is the most abundant fossil fuel. Coal is formed from living plants which died, decayed, and were buried by mud and other decaying matter. Millions of years of heat and pressure caused this organic matter and mud to change to coal. Coal deposits are found deep underground. Tunnels or mines are dug in order to remove them. At one time, coal mining was an extremely hard and dangerous job. Miners worked underground 10 or more hours a day, 6 days a week, using picks to break the coal loose. Many miners lost their lives in accidents, and others died of lung diseases from breathing the coal dust. Today, machines do most of the work in coal mines. However, it still remains a hazardous occupation. Coal close to the surface is removed by a process called strip mining. The soil on top of the coal is removed by huge shovels. Then the coal is removed. This method of mining destroys vast areas of land and vegetation. Today, mining companies are required by law to reclaim the land. That is, return the land as close as possible to its original condition. Most coal is burned to produce electricity. Half the electricity in the United States comes from power plants that use coal. Besides supplying energy, many substances are made from coal and are used as raw materials in manufacturing. Coke is the most widely used substance made from coal. It is an essential raw material in the manufacture of iron and steel. Other substances obtained in the process of making coke are used to manufacture different fertilizers, drugs, and dyes. The biggest problem faced by the coal industry today is air pollution. Scientists are looking for ways to limit the sulfur and other impurities that are released into the air when coal is burned. New kinds of equipment can remove many of the harmful pollutants. Although these safeguards are very expensive, raising the price we pay for energy, the cost of harming the environment may be far greater. While coal is the most abundant fossil fuel, petroleum or crude oil is the most widely used. It furnishes about 40% of the energy used in the world. Petroleum is easier to get out of the ground and transport, and therefore cheaper to use than coal. Fuels made from petroleum have a wide variety of uses. They provide power for automobiles, airplanes, ships, factories, farm equipment, trucks, trains, and many other kinds of machines. Scientists believe petroleum is formed from decayed fish and tiny ocean organisms that settled to the bottom of the sea. Millions of years of heat and pressure have squeezed the petroleum into nearby sandstone rocks. Deep below the Earth's surface, huge sections of sandstone contain petroleum reserves. Oil is trapped in the spaces between the grains of porous rock, almost the way water collects in a sponge. Above this layer of sandstone is a hard layer of rock called a cap. If this cap is pierced, the pressures which have built up in the earth will force the oil to the surface. First, however, these hidden oil fields must be found. Once, looking for oil was a hit or miss adventure. Today, sophisticated instruments study rock formations on and below the Earth's surface to discover where oil is located. When it is determined where oil is likely to be found, wells are drilled by a process that is both difficult and expensive. The wells may be on land or on the bottom of the sea. A drill bit, anywhere from 3 inches to 2 feet in diameter, is used to burrow into the earth. As oil is used up at the shallower depths, companies have to drill deeper and deeper. It is not uncommon to drill to depths of 30,000 feet in search of oil. Yet only about 1 out of 50 wells that are drilled yield enough oil to make a profit. Petroleum makes an excellent fuel in that it burns easily and produces a great amount of heat and power. But before petroleum can be used as an energy resource, it must be refined or separated into different fuels. Crude oil can be refined into gasoline for cars, diesel fuel for trains, trucks, and ships, a kind of kerosene for jets, oil to heat buildings, and lubricating oil for industrial equipment. Refined petroleum also serves as a raw material in manufacturing plastics, cosmetics, detergents, drugs, fertilizers, insecticides, and about 3,000 other products. Like coal, the production, transportation, and use of petroleum have created serious environmental problems. Tankers and offshore drilling accidents cause oil spills that pollute the water, damage beaches, and destroy wildlife. Fuels burned by motor vehicles, power plants, and factories are the chief source of air pollution in most cities. Many governments now have laws to control the location, construction, and operation of all types of energy facilities. The fossil fuel that is the most convenient, cheapest, and least polluting is natural gas. It accounts for about 20% of the commercial energy used in the world. Millions of people use natural gas to heat their homes, cook their food, and dry their laundry. Natural gas is formed the same way that petroleum is formed, and it is usually found in a solution with oil or in a separate layer immediately above an oil reservoir. Unlike oil, natural gas does not have to be refined. It can be used almost exactly as it comes from the ground, put into pipelines, and taken to homes and factories. Natural gas also burns more completely than either petroleum or coal and leaves little waste. According to most scientists, the world's supply of oil and natural gas can last only about another 50 years at the present rate of use, and our coal reserves may last another 200 years. While conservation efforts can extend our energy resources, our supply of fossil fuels is rapidly being depleted. One alternative is already being used. It is nuclear energy, the most powerful form of energy known. It is cheaper than coal, oil, or gas, and there is almost a limitless supply. However, the controversy over nuclear energy's safety has kept it from being more widely used. Nuclear power is the energy released when certain kinds of atoms are split. Atoms are the smallest unit of an element and the basic building blocks from which everything in the universe is assembled. Atoms of the element uranium are split in a process called fission and controlled in a nuclear reactor. A nuclear reactor produces heat energy which is used to boil water, which is turned to steam to drive turbines and generate electricity. Small nuclear reactors are used to power ships and submarines. Nuclear fission creates huge amounts of energy from a small amount of fuel. A single pellet of uranium about the size of a thimble releases as much energy as 160 gallons of oil. Unlike coal and oil, nuclear energy does not release pollutants into the air during use. However, nuclear plants threaten the environment in other ways. Radioactive wastes are produced by nuclear power plants and are extremely damaging to all living things. Since these wastes remain radioactive for millions of years, they must be stored so they will never escape and harm people or the environment. Scientists are still searching for the best method of disposing of nuclear wastes. Another danger nuclear plants pose is the possibility of a breakdown in the cooling system that would release harmful amounts of radiation. In most cases, large containment structures prevent radiation from escaping. However, in 1986 in Chernobyl, in the Soviet Union, an explosion and fire at a nuclear plant released large amounts of radiation into the atmosphere. Over 30 people died. Many were injured, and the whole town had to be evacuated to another area. Scientists believe winds carrying radiation to other parts of Europe may cause an increase in cancer. Thus, the threat of nuclear accidents is real, and the debate over the safe use of nuclear energy continues. Nuclear energy may yet prove to be safe and reliable, but oil, coal, and natural gas are still our main sources of energy for the present. With the limits of these non-renewable resources in sight, the challenge presented by the Earth's diminishing energy supply seems clear. In the short term, we must conserve energy supplies and improve the efficiency of power plants and engines, while at the same time developing new and safe energy resources for the future.
A spaceship supplied with electrical power by the energy of the sun. Large amounts of electricity generated by power plants using the ocean's tides. Modern windmills spanning the countryside generating electrical power. And an entire city heated by the energy found deep below the Earth's surface. These are not the far-fetched ideas of science fiction writers, but they represent actual energy resources that are being used in a limited way today and perhaps will play an even larger role in the future. Solar, water, wind, and geothermal energy represent energy alternatives to the non-renewable fossil fuels, coal, oil, and natural gas, whose supplies are rapidly being used up. Let's take a closer look at these natural resources to see what they are, how they work, and what possibilities they may hold for the future. The potential of energy from the sun, or solar energy, is enormous. The sun has always been the Earth's most important energy source, providing natural fuel for animal and plant life. In fact, all energy consumed by people has come from the sun. The sun is also responsible for creating winds, ocean currents, and weather. Enough sunlight falls on the United States in just 2 days to provide more power than the country's known reserves of fossil fuels. However, this energy is spread out over a vast area. The challenge is to capture it, concentrate it, and to store it, so it can be used to drive machines, to heat homes and offices, and to generate electricity. Solar energy may be used in a passive manner by constructing buildings to best take advantage of the sun's natural ability for heating and cooling. Applying the technology of solar collectors and solar cells are active methods of producing solar energy. The largest use of solar energy is for rooftop solar heaters to provide hot water systems for homes. Panels on the roofs of houses are usually black metal tubes covered with glass or plastic to reduce the loss of heat. The sunlight passes through the glass or plastic and is absorbed by the metal underneath. This heats the water that runs through the tubes and is used to heat the house. To use solar energy on a large scale requires many reflectors. Their curved, shiny surfaces focus the sunlight on one spot in order to intensify the heat. If enough heat is generated, steam can be created to move a turbine and produce electricity. Solar cells, or photovoltaic cells, are another method of using the sun to make electricity. The photovoltaic cells contain crystals, which help produce an electric current when sunlight strikes them. Since these cells are rather expensive, this method of producing solar energy is still limited. The other main disadvantage of solar energy is the interruptions caused by darkness and cloudy weather that would necessitate having to store energy for these times. Some scientists see the possibility of having a solar power station in space that would send energy to Earth using microwaves. This system could work day and night, eliminating the need for energy storage. While solar energy does not provide all the answers to our energy problems, it does offer a safe, non-polluting alternative to fossil fuels and may be an important part of our future resources. Like solar energy, energy from moving water is another abundant source of non-polluting power. 3/4 of the Earth's surface is covered by water, with currents and tides, which could potentially be transformed into electricity. The energy of moving water has been used to grind grain, to saw wood, and to lift objects. Some of these mills are still operating, but today water power is used mainly to generate electricity. Electric energy produced from moving water is called hydroelectric energy. Only about 1% of the world's energy comes from hydroelectric power. Water flowing over a dam or waterfalls turns a turbine, and the turbine turns an electric generator. A water power plant can operate only where water flows from a higher place to a lower place. The use of hydroelectric power plants is also limited because few are located near enough to the cities where the power is needed. Although water costs nothing, cannot be used up, and supplies energy without pollution, environmentalists are still concerned that building dams could affect the ecological balance of an area. Another form of water energy can be obtained from the ocean's tides. Tides are caused by the gravitational pull of the sun and moon on large bodies of water. Tidal energy can be used wherever there are high tides in a bay that can be enclosed in a dam. Power plants built along the seacoast take advantage of the energy created by the rise and fall of the water's tides. The movement of the tides is used to turn turbines and produce electricity. While tidal energy is limited to a few areas and can only operate at certain times for a short period, it can provide some relief from the dependency on a shrinking supply of coal, oil, and natural gas. Like water, wind is a source of energy that has been used for centuries. Sailing ships were probably the first kind of technology to harness the power of wind energy. On land, windmills have been used to pump water and turn millstones. And in rural America, the spinning blades of the windmill were once a common sight, generating electricity to run the farm. Today, however, farms require more energy than can be supplied by a standard windmill. To use wind to generate electricity on a large scale, there must be large windmills and a steady wind. There also must be efficient ways to store wind energy for use during times when there is no wind. Other problems that need to be solved include the placement of windmills where they will not interfere with the environment, and the construction of blades that will be long enough to generate enough power and strong enough to withstand enormous stress. Cost is another major obstacle. Although wind may be free, the machinery to harness it is still very expensive. Due to the high cost of equipment, lack of storage capabilities, and its undependable nature, no large-scale attempts to develop wind energy have been made. But scientists do not lack for ideas. Some have even suggested floating gigantic wind towers off the New England coast. While some see wind power as a step back with little practical application, to others it is a step towards an energy resource that is clean and safe. Out of all the possible future resources, perhaps the one that will prove the most productive is geothermal energy. Geothermal energy is a kind of energy produced from the heat deep below the Earth's surface. The temperature at the center of the Earth is about 11,000 degrees Fahrenheit, 6,000 degrees Celsius, which makes it potentially a very powerful source of energy. Scientists believe this heat is caused by the decay of radioactive materials deep inside the Earth. The heat is so great that it produces magma, or molten rock, which heats water that has seeped underground. This produces steam, which sometimes escapes as a geyser. Power companies drill into areas where this underground steam is trapped and direct it toward blades of steam turbines. In areas where underground steam does not exist naturally, engineers can create it by injecting water into hot rock. While there is only a limited number of places where geothermal energy can be used, it is already producing more electricity than either solar or wind energy. Perhaps the most dramatic example of geothermal energy can be seen in Iceland, a volcanic island near the Arctic Circle. The geothermal activity here is so great that the capital city of Reykjavik can be centrally heated from it. Although geothermal energy does not produce smoke, there is a large amount of sulfur in the steam that can cause serious air pollution problems unless it is removed. Still, geothermal energy like solar, water, and wind energy, is a lesser threat to the environment than fossil fuels. However, technological and economic problems still prevent these natural resources from being more widely used. Scientists are working to overcome these problems, as well as trying to discover other alternatives. Since no single energy resource will supply all the world's energy needs, many different sources will have to be developed. The sun, water, and wind are constants. These resources have always been there, making them our oldest natural resources. But they are also resources for the future.